Good morning, students. Students, today our topic is multiplication theorem on probability. Students, there are cases when we need to find the probability of occurrence of two events simultaneously. Suppose that we have two events E and F in a given sample space, and we want to find the probability of E and F. It means the probability of occurrence of E and F together. This can also be written as probability of E intersection F. We know that if we have written and between E and F, it means E intersection F. And in probability, sometimes we also write it as probability of EF. In place of writing intersection F, we can also write it as probability of EF. So in such cases, what we have to do, we have to use our previous result of conditional probability. We know that probability of E conditional F is equal to probability of E intersection F upon probability of F, provided probability of F is not equal to 0. So from here we can get another result. Probability of E intersection F is equal to probability of F into probability of E conditional F. Clear? So it means if we want to find the probability of E and F together, it means probability of intersection F, then if we have the probability of F and probability of E when F has occurred, then we can find the probability of E intersection F. Let us consider this as equation number first. Now we also know that probability of F slash E, or probability of F when E has occurred, is equal to probability of F intersection E upon probability of E, and this can also be written as probability of E intersection F upon probability of E, provided probability of E should not be equal to 0. And from here we can get the probability of E intersection F is equal to probability of E into probability of F when E has occurred. So it means if we want to find the probability of E intersection F, and we have the probabilities of probability of E and probability of F when E has occurred. If we have these two probabilities, then we can find the probability of E intersection F. So we can find the probability of occurrence of E and F together by using this formula also. So it means we can find the probability of E intersection F in two ways, either by using this formula or by using this formula. So if we combine these two results together, then we can write the probability of E intersection F is equal to probability of F into probability of E conditional F is equal to probability of E into probability of F conditional E. But the condition is that if we are using this result, probability of F should not be equal to 0, and if we are using this result, probability of E should not be equal to 0. This is known as multiplication rule. This is known as multiplication rule of probability. Clear? And we can extend this result of simultaneous occurrence for 3 events also. Here we have only 2 events, events E and F, and if we want to find the simultaneous occurrence of these 2 events E and F, it means probability of intersection F, then you can use any of these 2 results. Okay? Out of these 2 results we can use any of these results. And if we want to find the simultaneous occurrence of 3 events, then we can extend this result to 3 events also. Let's see how. Suppose that we have 3 events, event E, F and G, associated with a random experiment. So if we have 3 events E, F and G, and we want to find the simultaneous occurrence of E, F and G, it means if we want to find the probability of E intersection F intersection G, then multiplication rule for this case will be probability of E into probability of F when E has occurred into probability of G when E and F both has occurred. Clear? So this can be written as like this. If we want to find the probability of E intersection F intersection G, and we have the probabilities of probability of E, probability of F when E has occurred, and probability of G when E intersection F has occurred, then the multiplication of these probabilities will give the probability of E intersection F intersection G. Clear? This can also be written as probability of E into probability of F when E has occurred into probability of G when E and F both has occurred. We have just now before this we have discussed about this, that EF can be written in place of intersection F. It means EF denotes intersection F. Similarly, we can find the value of E intersection F intersection G in different manner also. We can write probability of F into probability of E when F has occurred into probability of G when E and F has occurred. Clear? So this formula can also be used to find the probability of E, F and G. We can also find the probability of E intersection F intersection G in this way also. Probability of G into probability of E when G has occurred into probability of F when E and G has occurred. Clear? So this, in this way also we can find the probability of E, F and G. Or we may also write probability of E intersection F intersection G is equal to probability of G into probability of F when G has occurred into probability of E when F and G has occurred. Clear? So we can use any of these results to find the probability of E intersection F intersection G. So this is called the multiplication rule of probability for 3 events E, F and G. Now let's discuss some questions how we can use these results to find the probabilities. So the first question is, two cards are drawn at random. Two cards are drawn at random without replacement. Without replacement from a pack of 52 playing cards. Playing cards. Find the probability that both the cards are black. Find the probability that both the playing cards are black. So in the random experiment we have taken out two cards without replacement from a pack of 52 playing cards, and we have to find the probability that both the cards which have been taken out from the pack of 52 cards are black. It means the first card that we have taken out should also be black, and the second card should also be black. It means both the cards should be black. So here we have to find the probability of B and B. It means the first card and the second card both should be black, or we can also write it as probability of B. This is the case. It means we have to find the simultaneous occurrence of two black cards. So by using the multiplication rule, this can be written as probability of B into probability of B when B has occurred. You know that probability of E intersection F is equal to probability of E into probability of F when E has occurred. So using this result here both the events are same. In the first event we have black, and the second event also we have black. So we want to find the simultaneous occurrence of two black cards. So probability of black and black can be written as probability of black into probability of black when black has occurred. Now if we have initially we have 52 cards. Initially we have 52 cards, and we have taken a card. We have taken out a card out of these 52 cards. Then the probability that the card that we have taken out is black will be, in total out of 52 cards we have 26 black cards. So the number of favorable cases will be 26, and total number of cards in the pack are 52. So the probability of taking a black card out of 52 playing cards will be 26 by 52. And now if the first card is black and we kept that card aside, जो हमने कार्ड निकाला है उसको हमने साइड में रख दिया और फिर से दोबारा से एक कार्ड निकाला. So when we draw again a black card out of the remaining cards, now we have only 51 cards. Out of 52 cards we have taken out one card. Now we are taking out second card. Now we have only 51 cards in total, and we already have taken out one black card. So out of 26 cards now we have only 25 black cards. So the probability of taking out another black card will be 25 by 51. It means probability of taking out black card at second time, when in the first draw we already have taken out black card, will be 25 by 51. Clear? So this is our required probability. Clear? Very simple. When we are taking out first card, we have total 52 cards and 26 black cards. So the probability of taking out a black card out of the given total of 52 cards will be 26 upon 52. And after that, since we are not replacing the card into the same pack, so if we take out another card, so now we have only 51 cards in total and 25 black cards in total. So the probability of taking out another black card will be 25 upon 51. Now let's take another question. Question is, a box of oranges is inspected by examining 3 randomly selected oranges. 3 randomly selected oranges without replacement, drawn without replacement. If all the 3 oranges are good, the box is approved for the sale. Otherwise rejected. Find the probability that a box containing 15 oranges out of which 12 are good and 3 are bad, is approved for the sale. So this is our question. There is a box of oranges which is to be inspected by examining 3 randomly selected oranges, and the oranges are drawn without replacement. And if all the 3 oranges are found to be good, the box will be approved for the sale. And if any one of those 3 oranges which have been taken out are found to be bad, then the box will be rejected. Now we have to find the probability that a box containing 15 oranges out of which 12 are good and 3 are bad is approved for the sale. So if the box has 15 oranges out of which 12 are good and 3 are bad, and we are taking 3 oranges out of those 15 oranges randomly without replacement, So what will be the probability that the box is approved for the sale? Clear? The box will be approved for the sale if and only if all the 3 oranges are found to be good. If any of those oranges are found to be bad, the box will be rejected. So here we will use our multiplication rule for 3 events. Clear? Because here we are taking out 3 oranges one after the other, and we need that the first orange that we are taking out should be good. Then after first, the second one which is to be taken out should also be good, and the third one should also be good. Only in this case the box will be approved for sale. So now we can remove this. So if we represent good orange by G, then what we are required to find? We want to find the probability of G intersection G intersection G. It means the first orange should also be good, second one should also be good, and third one should also be good. All the 3 oranges should be good if the box is to be approved for the sale. So to find the probability of G intersection G intersection G, it means probability of 3 good oranges, which can also be written as probability of G, G and G, is equal to, by multiplication rule, it will be probability of G, the first G, into probability of G when G has occurred. It means probability of getting second good orange when the first is good, into probability of getting third good orange when the first 2 oranges which have been taken out are good. So probability of getting the first orange as good orange is, in total we have 15 oranges, and out of these 15 oranges 12 are good. So the probability of taking out a good orange is 12 by 15. Probability of G is 12 by 15. Now since the experiment is going on without replacement, so if we take out another good orange, if we take out another orange from the remaining oranges, then after taking out one orange, now we have 14 oranges in total, and after taking out one good orange, now we have only 11 good oranges. So the probability of getting second orange as good orange is 11 by 14 only. Now if the first 2 oranges are good oranges, then the probability of getting the third orange as good orange is given by, now after taking out 2 oranges, now we have only 13 oranges in the box, and since we have taken out 2 good oranges, so the number of good oranges in the box are 12 only. So the probability of getting third orange as good orange is given by 12 by 30. Sorry. Now the good oranges are 10 only. After taking out 2 good oranges in the box, we have only 10 oranges. So probability of getting third orange as good orange is 10 by 30. So this will give the probability of getting 3 good oranges out of 15 oranges, in which 12 are good and 3 are bad. So the probability that the box is approved for the sale is 12 by 15 into 11 by 14 into 10 by 30. Clear? So this is the application of our multiplication rule in case of 3 events. Now let us take another example. Three cards are down successively 3 cards are drawn successively without replacement from a pack of 52 playing cards, from a pack of 52 well shuffled cards. What is the probability that first 2 cards are kings, and the third card drawn is an ace, and the third card drawn is an ace. So see here, out of 52 well shuffled cards, we are taking out 3 cards successively one by one, that too without replacement. Then we have to find what is the probability that the first 2 cards are kings and the third card drawn is an ace. So we are taking out 3 cards, and we have to find the probability that the first 2 cards should be king and the third should be an ace. So we want to find the probability of K intersection A. It means first one should be king, second one should be king, and the third one should be an ace. We can also write it as KKA, probability of king and ace. When using multiplication rule, this can be written as probability of K into probability of K when K has occurred into probability of A when K and K has occurred. It means KK has occurred. Clear? So we have total 52 cards, and out of 52 cards there are 4 kings. So the probability of getting the first card as king is given by 4 by 52 into, now since the experiment is going on without replacement, so the first card is kept aside. Now we are taking second card from the remaining cards. So now we have taken out 1 card, so we have 51 cards only, and we have taken out 1 king, so we have now 3 kings only. So the probability of getting the second card as king is given by 3 by 51. Now because after taking out 1 card which is king, we have only 3 kings and 51 cards in total. So the probability of getting the card as king is given by 3 by 51 into, now after taking out 2 cards, in total we have only 50 cards in the pack. And now in the third chance we need to find the probability of getting an ace. So how many aces are there in a pack of 52 cards? There are 4 aces, and we have not taken out any of these aces, so we have 4 aces at this time. So the probability of getting an ace out of these 50 cards is 4 by 50. Clear? So the probability of getting the first card as king, second card as king, and third card as an ace is given by 4 by 52 into 3 by 51 into 4 by 50. Clear? So it is very simple to apply. And last question. Last question is, an urn contains 10 black, an urn contains 10 black and 5 white balls. Two balls are drawn. Two balls are drawn from the urn one after the other. Without replacement. What is the probability that both drawn balls are black? What is the probability that both drawn balls are black? So there is an urn which contains 10 black and 5 white balls. It means there are 15 balls in the urn, out of which 10 are black and 5 are white. And 2 balls are drawn from the urn one after the other without replacement. And we want to find the probability that both the balls which are drawn are black balls. So it means we want to find the probability of black and black, BB, probability of B intersection B. Then using the multiplication rule, this can be written as probability of B into probability of B when B has occurred. So since we have in total 15 balls, out of which 10 are black, so the probability of getting the first ball as black ball is 10 upon 15. Now since we are taking out the balls without replacement, so after taking out one ball, now we have 14 balls, and after taking out one black ball, we have only 9 black balls. So the probability of getting the second ball as black ball when the first ball is black is 9 by 14. So this is the probability of getting 2 black balls out of the 15 balls, in which 10 are black balls and 5 are white balls. Clear? So in this way you can use the multiplication theorem or multiplication rule to find the relative probabilities. So try more and more questions on this topic. Thank you.